Hi, today I want to do a little update video on the state of the wind tunnel and turbine testing. There have been several of you who've submitted turbines for testing, and in the last turbine video I did, I made some changes to the dyno setup. Well, I'm about to make some more. This is because I've received several turbines that don't work in the current setup, for a few reasons. The first being scale. The wind tunnel is pretty small, and when our turbines are scaled down to fit in the wind tunnel, the resulting lift force they can produce is also quite small when you compare it to the second issue, friction. I found that many of the submissions I received don't produce enough force to overcome the magnetic cogging in the generator. So I redesigned the mount and replaced all of the bearings as well as the motor with extremely low friction bearings. You get the idea. Some designs still don't produce enough lift to reach their theoretical maximum power points. In fact, after speaking with one of the designers, some of them might be getting stuck in a performance valley, and they can't escape it without a little help. So I tried helping them with a drill, and that went as well as you might think. Using a drill to start the turbines is fun, but also not something I want to continue doing. So the actual solution to friction and the performance ruts is to actively drive the turbines with a motor, like the one I literally just removed. Let's go ahead and look at the new dyno, and I'll try to explain how it works. The new dyno has two main assemblies, and they're both fairly simple. The first is the main body. It contains the load cell and a feature to hold two of the low friction bearings. Next is the motor assembly. It consists of a bidirectional lever and a concentric shaft, all mounted to the base of the motor. This assembly slips into the two bearings of the base, allowing the lever to transfer force to the load cell. During the test, we'll accelerate the turbines using the motor, and we should be able to measure an opposite and equal force pushing against the load cell. If we do this 2 times, once with the tunnel off and another time with it running, the difference between the 2 runs should be, in theory, the force generated by the turbine, with the friction and active acceleration forces removed. I'm still not sure what to call this type of dynamometer. Maybe it's an active reaction force dyno? Anyways, let's go over to the wind tunnel where I have the dyno installed and run the NACA 0018 turbine so we can see if this works, or if I've just wasted a whole bunch of time designing and reprogramming my testing system. Let's go ahead and record a baseline measurement by first homing the turbine and running it with the wind tunnel turned off. The force we measure should be negative because the force is acting in the opposite direction that we're driving the turbine. Now let's turn on the wind tunnel and see what happens to the graph. I think the results speak for themselves, and they seem reasonable as well. We were getting 7 to 8% efficiency with the NACA 0018 turbine on the brake dyno.
If you're anything like me, you're probably wondering what the graph would look like if we didn't subtract the baseline. So, I ran the turbine again with the wind tunnel on, and this is what the graph looks like without the baseline removed.
I think these are good results, so I'm tempted to go ahead and start using it. But let me know what you think down in the comments. If you like what I'm doing, go ahead and leave a like on the video, comment, and don't forget to subscribe if you want to see more of these videos. Oh, and I have a Patreon if you want to help support these projects. Okay, thanks, bye!